And I'm sorry, what? What you?
She said it'll be longer than 15 minutes.
Yeah, today's going to be longer than 15 minutes. Thank God. They replaced that tower with, the tower that blew out. They think that either a power surge or lightning came in on that camera tower that runs the camera. And so they had to take the one out of the conference room and put in there. I told them to give me a webcam, and I said next time it goes out, I can at least improvise with a webcam. Just plug it in and shoot it toward the screen, and that way everybody can see it. That'll work, and I can record. So they're going to get me a webcam that will suffice as a secondary, because I don't want to. Because if that one goes out, then we're sunk. Okay, so we're hitting the whiteboard, and I don't know, did I leave off with the family of graphs?
No.
Okay, well that's what we're going to start off with. Okay, so go ahead and write these down. Now they're very rough, but you can actually find these on the internet. Go to Google and I think they're called either parent graphs, like your parents, or they're called family of graphs, one of the two. And you can print it out and put it out, whatever. The whole point is you need to recognize the certain types of graphs for your variable. And this is where chapter 2 starts off. Okay? I got to hear you.
I was just saying, I sort of kind of remember.
Okay, you remember it? Good. Well, that's a good thing, because it should be a review. And you start to see that f of x is equal to x to the first power. That's a linear. That means it's a straight line. And usually that's the y is equal to mx plus b. That's what you were, that was drilled in your head, what, 7th, 5th, 6th, 7th grade, somewhere in there. And how you plotted points, and you connect the points, and you get a line. All right? You spent most of your 5th, 6th, 7th grade learning that. And then in Algebra 1 and 2, you started bringing in the quadratic, which is the x squared function, which is your parabola. And then after algebra, the second part of Algebra 2, you probably brought in the others, okay? If not all of them, some of them. So what I want you to be able to do, and what Chapter 2 is trying to get you to do, is be able to sketch a graph without using mathematics, okay? And of course, without using your calculator, because that goes beyond saying. But you should be able to look at a function, and be able to ascertain at least 3 or 4 things about the function, which includes the function itself. What does it look like? What is being done as far as compression or stretching? What is being done as far as a vertical and a horizontal shift? Now, you should be able to ascertain all that by looking. Now, in order for you to look at a horizontal and vertical shift and all that stuff, you have to learn the basic rules or the basic form of these functions. And I'll show you that in just a minute. Now, why do you need to learn this? Because when you get into trig and get into calculus, you're not going to have time to graph a function. You're going to be sketching a lot of functions, and you're going to be utilizing the things that we're learning in Chapter 2 and Chapter 3, Unit 1 and Unit 2. You're going to be using those tools to sketch a graph quick, or be able to pull out or extract information about a graph, whether it be an algebraic graph like these, or whether it be a sine, cosine, tangent graph. Because and that's the good thing about this, the things that you learn about these graphs, you're going to carry into trig next semester, as far as the amplitude, as far as compression, as far as the vertical and horizontal shifts. All of that is going to be included with any graph that you graph from here on out, whether it's an algebraic graph, a trigonometric graph, or a calculus graph. So these are the bases. So this is like the bottom floor of It's called graph transitions, is what it is. Okay, so if you want to sound important, call it graphic transitions. Now, go to the next page. I'll show you how these look. Okay. I'll wait to give you a couple more seconds to draw those. And like I say, you probably can Google it and Google parent graph, and you should be able to find it. Parent graphs. And the ones that I've shown you here are the basic graphs, except for one. I messed up one. I was just in a hurry. That's why we have pencils, right, with erasers. I never have been able to understand a pen in math. And I'm 53 years old. I've never understood a pen in math. Okay, there. All these are the basic forms. What do you mean basic forms? Well, when you go buy a car on a new car lot, you have different stages of those cars. You have different models. You have the Mustang, the basic Mustang, and then you have the Mustang GT, and then you have the Mustang blah, 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 just like you have a truck. You have a truck, F-250, and then you have an F-250 XL, and then you have an F-250 XLT. What comes with those different models? What? Weapons? No, don't say weapons, you're racist. If you buy a different model, okay? If you buy a different model, then you have more bells and whistles. Or something, say weapons, whatever you want to say, okay? You have different, like, the basic model, and these are all basic models. If I add a vertical shift, that's like adding air conditioning. If I add a horizontal shift, that's like adding heated seats. If I add resting, that may be different from a 2-door and a 4-door. You see what I'm saying? So each one is compared to these basic models. Now, how will you see these models written? You're going to see them written like this for the quadratic. You're going to see f of x is equal to a times x plus h, quantity squared, plus k. I'm just using some examples. For the absolute value, f of x is equal to a absolute value of x plus h. Oops, my bad. Squared, or not squared, absolute value of x plus h plus k. F of x is equal to a times 1 over x plus 4, x plus h plus k. So here's 3 examples. Okay, the first one is a parabola. The second one is absolute value function. And the third one is a 1 over x function. Now, all 3 of them have some things in common. A is going to be equal to orientation. If it's positive, that means it's going in the normal way. Normal based on the parent graphs that you just saw. What if it's negative? It's going opposite of the normal way. So if you have a parabola going up, opening up, or concave up, what is a negative in front of that x squared going to mean? It's going to be concave down or opens down. Capiche? It's going to go to the opposite direction. So a negative A would mean opposite direction. Because in physics, in science and math and accounting, what does negative and positive mean? Direction. That's all it means. Positive means above, negative means what? Below. Whether you're in accounting, or whether you're in science, or whether you're in math. In math, sometimes it can mean right and left, but it always means direction. What else can orientation tell you? Compression or stretching. So A tells you 4 different things, or 3 different things: direction, compression, or stretching. What does H tell? What does H tell us?
That's it. Left to right.
What's that called? Starts with H.
Horizontal.
Horizontal shift. Good. Horizontal. Horizontal shift. Okay? The horizontal shift, this is the only time where you see the opposite. So if you have a negative H, that means just moving to the right. If you have a positive H, that means just moving to the what?
Left.
Just take my word for it. If you don't remember it, take my word for it. Now, I'm gonna test some of y'all, see if y'all are up to par. If A is the orientation and H is the horizontal shift, then what do you think K is? The vertical shift. Y'all are on fire. K is equal to the vertical shift. The vertical shift is as normal. Positive means what? Up. And negative means what? Down. Now, a lot of you say, well, that's good, that's fine. This one is the one that makes up Unit 2. Okay? What do you mean? Well, in order to do Unit 2, you have to start with a trinomial, and you have to get it in that form, thus completing the square. Okay? Hopefully, you had a teacher with a backbone in high school that taught you completing the square. Or you had a teacher without a backbone that told you to use the calculator all the time. So if you had a teacher in high school with a backbone, then you should give that teacher a hug whenever you see them, because you got your money's worth, and that's what you're going to be. That's a Unit 3 altogether, Unit 3. So if you had a teacher without a backbone, you're going to have to reach down and dig a little bit and follow what I say so I can teach you how to be up with everybody else. Will you see completing the square in calculus? Yes. All 3 in DFQ, you're going to see completing the square. So it's one of those things that you're not going to be able to get away from. Then what about this unit? What's Unit 1? Unit 1. Unit 1, they're going to give you some like these, and you tell what the vertical and horizontal shifts are and stuff like that. So Unit 1 is a little bit easier because you don't have to do completing the square. But we're going to do it anyway because I'm going to kind of integrate the two. So these are going to be given in Unit 1. In other words, you don't have to find these forms in Unit 1. Unit 1, they're going to be given to you. So you don't have to think. Okay? Now, what else should you be able to tell with sketching a graph? Well, you should be able to tell some of the following. 1 second. I figured you were going to do that. What was that? You all right? Sound like somebody dying. Don't die on us. We won't talk about it. Okay. What else can you find? I'm going to put these in blue because these are additional things that you can find when you know how to sketch a graph. 1, domain. You should be able to look at a graph and be able to tell what the domain is. 2, what's after domain? Range. 3, you should be able to tell increasing and decreasing values. line of symmetry. All of those things you should be able to tell. So in Unit 1 and Unit 2, for the next 2 or 3 weeks, this is all we're going to be doing. Okay? Now, you can't do completing the square if you don't know the shortcuts. And you can't find the x-intercepts if you don't know how to do the reverse FOIL and the shortcuts. So if you haven't learned those shortcuts that I wrote down the other day, you need to be doing the review section and you need to be sending those questions in. Okay? Now, let me give you an example of what we're talking about. Well, let's say that I give you f of x is equal to 3 times x plus 4 minus 2. So at this point, we know we have an absolute value. So we know that we're going to draw a graph with absolute value. Now the normal absolute value looks something like what? Like that. Right? So we're going to take blue marker. We got a horizontal shift of 4 to the left. So 1, 2, 3, 4. And then in Verde, we're going to have a vertical shift of 2 what? Down. So now our origin of our V is right there, but we're not done. So that's our vertical shift. And then our horizontal shift is right here. And now this 3, we'll do it in, I don't like to use red, magenta. This 3 tells us it's going to be narrow. And it's a positive, so that means it's opening upward. So, how do you know that? Well, I'm going to tell you. If A is between 0, I don't know what's wrong with this. Oh, I know. Somebody put this marker down here and it's picking it up, I think. If A is between 0 and 1, meaning a proper what? Proper fraction. If you have a proper fraction for A, proper fraction, that means it's going to be wider than the what? Than the normal parent graph. Okay? If A is greater than 1, okay? If A is greater than 1, however you want to write it, A is greater than 1, I don't care how you write it. If A is greater than 1, then you're going to have an improper fraction. If you have an improper fraction, that means it's going to be narrower than the black dotted line. So now we can sketch the graph. And I'm going to take my handy dandy. We'll use that. Since it's Clemson Fiasco week, we'll use burnt ass orange. How about that? That's the only orange I got. Now, a supporter would be like, okay, a fanatic would be, oh, you can't use that, that's not the right color. Shut the hell up. And people irritate me. I'm sorry. Y'all know what I'm talking about. So that would be the graph. Now, what's the domain? The domain is all real numbers. How did you know that, Hubert? Well, what did I tell you before? If you have x to the first, x to the second, x to the third, x to the fourth, x to the fifth, x to the sixth, x to the seventh, it's going to be all real numbers. Yeah, if you did that, yeah. All reals, you had, doesn't matter. You can write either. Okay, there's nobody's going to put handcuffs on in jail if you put all reals. Okay, So the domain, we'll put it down here. We're going to write it in burnt orange. Domain is all reals. Now, if you use interval notation, that would be negative infinity to what? Positive infinity with non-inclusive parentheses, because somebody tell me what number represents infinity. I'll give you a $100 bill. All right, you can.
Right.
And x such that x is between negative infinity and what? Positive infinity. Sorry, I'm boring you. There you go. That's interval notation and set builder notation. Do I care? No. So, but if the directions say, if it's all real numbers, put the R to the R. If it tells you to do that, you need to do it. What? X such that, this is a straight line. These are braces. I can't write braces, especially on this, in this corner left-handed. Okay? X such that X is between negative infinity and what? Positive infinity. That's called set builder notation. Okay, what's the range? The range is from negative 2 to what? Infinity. So range, negative 2 to what? Infinity. Now that one, you're going to write with a bracket in interval notation, because y is generally not written in terms of set builder notation, but it would be y such that y is greater than or equal to negative 2. So you could write it like that. You could say y such that y is greater than or equal to negative 2. So that would be set builder notation. Everybody with me? How we doing, Oconee? Oconee and Pendleton?
Good.
Good. Okay. Now let's draw a plane. Because let me go through and tell y'all something. I'm going to go to another board here. Get with my ankle. I hate this thing. Domain. Range. Increasing. And decreasing. So which one is the only one that has to do with y? Okay, so when I ask for increasing and decreasing, why do y'all give me y values? I don't know. The only thing that you give me y values on is the range. And it's how you're explained about increasing and decreasing. Think of increasing and decreasing as a plane. You know, a plane, not a plane like a window plane, like a plane of, like a flying plane, okay? All right, so we're going to take a plane, if this thing will let me do it. And I just want you to, I'll draw it way down here. There's a plane. Which way do we read?
Left to right.
Left to right. There we go. There's a plane. See the plane? All right, so what's this plane doing?
It's blind.
And what's it doing from left to right?
It's landing.
It's landing. How do you say landing in plain talk? Starts with a D. Descending. So this plane from negative infinity is where? Right here. See it? Negative infinity. Okay? Why are you on the domain? Because I just told you. Domain, increasing, decreasing, and what values? X values. Range is the only thing in y values, so I'm not going to the range. So from left to right, from negative infinity, to negative 3, or what is it, negative 4? So from negative infinity to negative 4, I'm what? Descending. What am I doing from negative 4 to positive infinity? Ascending. So if you want to write descending and ascending, that's fine. But another word for descending is what? Decreasing. You're decreasing from negative infinity to -4. Okay, now we're going to get into a little bit of theory here. Okay, and then I'm increasing from -4 to infinity. And a lot of people say at this point, well, Hubert, why did you put a parenthesis on -4? Because that's a closed circle. Michael Jordan, all right? Greatest of all time. When he would leave the floor to dunk the basketball, where was he, half court when he jumped? Okay, it was about half court when he took off. But anyway, top of the key. He would get to a certain point where he was actually what? Flying, because he would either go up or what? Down. For a millisecond in time, when you throw a baseball up in the air, there's a millisecond where it's either going up or what? Down. So it's technically flying. So I cannot hold this particle in space right here on the 4 constantly, because it's neither going up or what? Down. So that's why when you're talking about increasing or decreasing, you're not, I hate this thing, you're not going to have a bracket, you're going to have a what? Parenthesis. So make sure you take your highlighter and you highlight that parenthesis, because the test and the homework will mark it wrong if you put a bracket there on increasing and decreasing. Now, of course, the line of symmetry is where? We'll do it in a different color. We'll do it in that dang old Georgia red. How about that? Dang old dogs. There's the line of symmetry. That's the difference between a Georgia fan and a Clemson fan. If Clemson loses, it's everybody's fault. If Georgia loses, Georgia fans will say, we either got our ass whooped or we choked. They'll tell you that. But if Clemson loses, it's the fans' fault, it's the referee's fault, it's the football's fault, it's the wrong football. Watch Facebook, you'll see what I'm saying. As soon as Clemson loses a touchdown or loses a call, them referees are against us. Y'all freaking crazy. Anyway, that's how. Now, hopefully, you remember seeing all this.
Hated it.
Okay, why'd you hate it?
I didn't like doing all the writing.
You didn't like what?
I didn't like doing all the writing.
Oh, okay, well. I'll give you a drop slip.
I tried that.
Oh, you did?
Yeah.
Didn't work? Oh, well. Usually quitting don't work unless you end up in a ditch, in a box down by the river, you know. What? What?
And when do you use the bracket? And then when do you use...
Bracket is when you include -4. Okay? The reason you can't include -4, remember, Michael Jordan, he's neither going, at one point in space, the vertex, the highest or the lowest point, you're neither going up or what? Down. So you can't say you're one or the other, so you have to leave it with a parenthesis. Now, if you notice, I used a bracket where? At -2, because I am at -2 as far as the range goes, and then I'm going up. So I'm not doing an up or down sequence with the range. Okay? You have to treat the increasing and decreasing as Michael Jordan or a ball or a bullet. If you shoot a bullet, okay, what design does it make? It makes a up and then what? Down. It makes a parabola. Same thing with the V. It's going down. You're going down, and then you're what? Going up. So you've got to treat that point, that vertex, as neither going up or down, because technically for a millisecond you're just there in space. You're not moving up or down. Okay? All right.
Parentheses after the infinity.
For the reason you have a parenthesis after infinity is because, tell me what number represents infinity? Nobody knows.
Makes sense.
Huh?
It makes sense.
Like I say, I don't use math, I use just layman's terms.
Okay, but that, I
It
get
sticks with you. If you say to yourself, okay, what's the number for infinity? You'll say, I can't give you a number, so you don't get a bracket, you get a brace. I mean, a parenthesis. Okay, Easley, Oconee and Pendleton. Do you remember this?
Yep. Yeah.
One yeah, 2 years. Oconee, what do y'all say?
Yep.
Okay.
Did they hear us?
I think one nod and a yep from Oconee.
For real? Hey.
They're waving at y'all. Okay, I don't know if they can see y'all or not, but anyway.
Really? Oh, look, we
They can see y'all.
everybody.
Yeah. That's the good thing about Polycom. We're just not all looking. Okay. Okay, now let's do a nerd. Let's do a nerd. Y'all think y'all can do it?
No.
I don't think you can either. I think you might as well just give it up.
It's just the +4 is the
It's always the opposite.
right.
So here's one. F of x is equal to 1/2. Yeah, might as well quit. Because y'all can't read the tape measure. X minus 2 to the 3rd power plus 1.
That fraction is thinking, y'all.
Here I go, Bubba.
Good. When in doubt, give up. 1/2 means it's going to be what? You're going to wide. It's going to be wider.
Yes, because it's
Because it's between 0 and 1.
I
Y'all feel good about yourselves.
I do.
So you don't have to wear too much makeup.
I feel like-
Local.
Oh! Okay.
That was smarter than I did when I woke up this morning.
Y'all ever seen that kind of girl?
Yes.
Got a dark face and a white neck or a lighter neck?
I was watching Willy Wonka last night.
I was too. Me and my sons, we watch it every time it comes on.
Hey, y'all are weird. So you know. Wait a minute. Okay, that's right. Okay, cool.
Now,
It is. Wait, no.
how do you know what it looks like? You go back to your parent graph.
It's like it.
What does your cube look like? It looks like the squiggle.
So it looks like a dangerous.
Yeah, like Saturday Night Fever.
What's his name?
John Travolta.
Yes.
So, I'm just going to draw a graph, and I'm going to draw my origin. Now, the parent graph looks like this. So the origin is right here. Okay? This tells us, let's take our blue highlighter. Y'all are just so blessed to have all this animation. There's -2, so that means take our blue pen, and we're going to say horizontal shift of 2 to the what? Right. So 1, 2. Okay. Now we're going to take our green for Dave, and we're going to do a vertical shift of 1 what? 1 up. So there's our new origin. So vertical shift of 1 up. So now, technically, we could draw this, and I don't know, it won't let me do it because I haven't had training on this yet. So we could move it right there now. But I can't move, so I'll have to just draw another one. But instead of drawing a normal one, we're going to take our burnt orange, and since our burnt orange, that sign and that, the sign tells us plus, and since it's not there, it's considered to be a what? A plus. Okay, so that means it's going to look like the black line, but when you have a 1/2, that means it is stretched along what axis? Along the x-axis, and that means it's compressed along the what? The y-axis. So what does, if you was to take a balloon and you was to pull it on the right and left side, or push it on the the vertical side, what would happen to the balloon? Would it get wider or would it get thinner? It would get wider. So instead of drawing the black line like it normally is, I'm going to make it wider. So your finished product looks something like this. Now do the domain range. Now the good thing about a cubic function or an odd function is the domain and range is what? All real numbers, both. And that's a big VAR with two lines in front of it. Let's just get away from that negative infinity to positive infinity. Let's just write, as far as the domain and range, domain is all real numbers. Range is all real numbers in respect to y. So you might want to put a y right there, a sub y. I don't know what the heck that is on that other one. When I'm on the left side of this board, it does funky things, so my left. Okay, so if you want to put an X right here, you can put an X. Okay, what's good about a cubic function or an odd function as far as increasing and decreasing? It's always increasing. So you can say increasing from negative infinity to positive infinity. Now, it is best when you're talking about decreasing to say negative infinity to positive infinity, because you're actually saying what route the plane is going. So, and it does have a line of symmetry, but the line of symmetry is not defined. It was well here, but it would be the y-axis. But we're not going to worry about that. Line of symmetry would be y is equal to 1. Oh, wait a minute. No, I need to move it. Hold on, I messed up. Let me erase. I was supposed to be in the green. I was supposed to be right there. I messed up. I suck. Hold on. Y'all were right. If it's in the green, I just messed up. Let's go back to the burnt orange. There we go. We're going to need to do something like that. There we go. And the origin now is not right here. It's right there. Sorry. There we go. So it looks something like that. The line of symmetry is where x is equal to 2. Okay? Now, there's a lot of different things in chapter 2, and I'm expecting for y'all to send me questions, but a lot of chapter 2 is basically what we're doing right now. Okay? I don't know how much of you have had exposure to the vertical and horizontal shifts. I don't know how many of you have had exposure to the different parent graphs. Okay? So if you need to, take your handy dandy Google, and let's see what it looks like so you'll know how to pull it up. And pull up parent graphs. Look at there. There they are. It's a miracle. So let's just click on one of them. And you can print that out and put it on an index card if you need to, or put it on the front of your notebook. Or you can be like 10% that's not going to do it, and then you're going to whine about not being able to pass, math, and then you'll change your major to a underwater firefighting degree, not get a job, and then complain about the student loans. Okay? We are what? Decisions. So own up to them. If you don't like this one, you go down here and do this one. Knock yourself out. I like the one that has the hyperbola. There's the that's the opposite. This one don't have the hyperbola, which is the not the opposite, but the inverse of the parabola. So if you could find one with a hyperbola on it, that would be good. I don't see one. I'm looking for hyperbola. If y'all know what hyperbola is?
I forgot what
It's
it
like
was.
two, like,
Y'all
it's like
suck.
two little
Oh,
parabolas.
that one right
So
there?
you just cut it like an oval. and-
No, that's a volcano.
Oh yeah, I was thinking volcano.
A hyperbola is a sideways. Just let me pull up hyperbola. I don't know why they don't have it on the graphs, but let me just do hyperbola. Hyperbola.
Volcano.
There you go.
Oh, I knew it.
There's a hyperbola right there.
It-
And see, if you turn it sideways, you say, okay, there's a parabola right there. But it's going right to left. Okay? So that's a hyperbola. Capiche? Okay. So let's look at, I even pulled up dadgum PowerPoint. Look at there. I am on fire today. Look at there. Even got the little graph right here. I can draw on it. So, continuous. Now, this is interval notation. Again, you should already know this. If you have an open circle or a vertical asymptote, or it's exclusive. Exclusive means that you cannot use that point. So you're either going to use a parenthesis, an open circle, or a vertical asymptote. Okay? We'll get to this later when we do piecewise functions.
Yes.
Okay? It's not a big deal right now. Big deal right now is the review and make sure you understand some of the things that I went over today. There it is, domain. Domain of this function is all real numbers. What's the range? 0 to infinity. You should be able to look at it and boom, tell me what it is.
Yeah, you see, I did that. I did it.
You own it. All right, domain. Negative infinity to 3 with a parenthesis. Then from 3 with a parenthesis to what? Infinity. What is the range? Negative infinity to 1, then parentheses, and then 1 to what? Infinity. So you need to look at that. That open circle, not only, remember, if the domain is affected, so is the what? Range. You can't affect one without the other. Remember? The 5 gallons of Kool-Aid, you get 5 gallons of ice. You change the color of the Kool-Aid, it's going to change the color of the ice. The domain dictates the range. So if one's affected, both are affected. There's our volcano. What's the, okay, be careful here. What is the domain? Negative infinity to what? Okay, I don't know if I've told y'all this. I don't understand mumble and I don't understand whisper. I understand volume and articulation. Okay, so let's try that again.
Okay.
Negative infinity to what?
-2.
That's articulation, good. And from -2 to what?
Infinity.
Infinity. And what goes on -2? The parentheses. And what's our range?
Okay, 0 to
0 to,
infinity.
do you touch 0? No. So 0 gets a parenthesis. Why? Because you, by the arrowheads, you can't tell whether you ever touch the x-axis. So therefore, it's 0 to infinity with exclusive or parentheses on the 0. Next. Increasing and decreasing. We already talked about it. Okay, what's this one doing? It's increasing. What's this one doing? Decreasing. Make a note, constant means a horizontal line. So you will have some piecewise functions, and there is a test question, I remember it. It will have a increasing, then it'll constant, and then it'll decrease. And you got to tell which, what, x values or y values? X values. Remember, it's a plane. It's either going up, horizontal, or going down. There's one right there. So it's decreasing from negative infinity to what? 1. Then it's, okay, parentheses. Then from 1, because this one cancels this one out, from 1 to 3, it's what?
Increase.
And those increasing meaning what? You got a bracket on the left one. You got a parenthesis on the right one because you're neither going up or down or constant. It's in flux. So a parenthesis there, and then to infinity is constant. Now you will have some, and I'm being very lenient with that because there's some books that will put a bracket here, and some will put a parenthesis. So it's something that's, which came first, the chicken or the egg? Or is 2 a prime number? You have some books that say 2 is not a prime number. You have some books that say 2 is a prime number. So that's one of those things that people kind of fluctuate about. Okay? See, on this one, from 1 to 3, it's increasing, and they put a bracket. So, and then from 3 to infinity. So in that case, you could use a bracket. That's not gonna stop you from making an A on the test. I'll give you that one. Mess up on that one. Okay? Constant function, we already talked about that. There's your x to the first power. That's called a what function? A linear function. A parabola. We're going to talk about this when we come back, because let me see what time it is, because I don't want anybody to explode. Yeah, y'all won't explode in a minute. So we'll talk about this, and that's when you have to plug in negative x, and you see if you get the same answer as f of x or negative f of x, and if that's whether around the y-axis or the origin. We'll go back to that. Look, there's the cubic function, and we'll talk, there's the negative f of x. We'll talk about that. And we got to plug and chug in that. We'll talk about that later. I want to get back to the family of graphs. This is called a saddle, because it looks like a saddle. It's also called hidden behavior. Write that down. Hidden behavior. Sometimes you look at your graph on your graphing calculator and it will look like a parabola, but it's not. It's a saddle. And you have to zoom in several times to see the hidden behavior. The hidden behavior is this saddle area right here. So sometimes, be careful. You might, especially when we get into max and min, this one's got 2 mins and a max. And if you just look at it on your calculator from zoom out, it looks like a regular parabola. And a regular parabola only has 1 min. So that's not a parabola. So that's something to remember. And we're going to get to this. That's where you do the negative. I'm not worried about that. There you go. Square root function. Cube root function. I didn't show you this one. Add that to your family of graphs. That's the one I forgot. I always forget that one. Look at that one. Go ahead and put that. I think there's one space down in the bottom right-hand corner of your family of graphs. Make sure you add that one. And you can just write odd root, because the odd root, the only thing that's going to happen if you have the 5th root, it's going to flatten this area out a little bit more. So that's the only thing it does. So the cube root or the 5th root or the 7th root or the 9th root will look like this. Absolute value. And we'll talk about line of symmetry. We'll get into that. That's where you plug and chug to see if it, and we'll get into that Wednesday, what's the day? Wednesday? Friday. We'll get into that Friday. Okay? And that's the second part of this section. So right now, you should be working on your review and your orientation and 1.2, which is interval notation. And then, after that, you should work on some of 2.1. But if you don't do 2.1, don't worry about it because we're not finished with it yet. Okay? Comprende?
Go.